For my final project, I wanted to look at the topic of crystal structures. So I first have to answer the question of what are crystals? Crystals are solids whose atoms are arranged in a highly ordered structure. Crystal structures are oftentimes densely packed together. What allows this to happen is the fact that the atoms in crystals all are very similar. So all of them being so similar means that their atomic radii are also very similar, allowing them to be ordered and very densely packed together. The properties of these crystals can differ greatly depending on what material is used to create them. Some crystals may be much better at conducting heat, while others may be much better at conducting electricity. There's also the big difference in optical properties that may be apparent in some crystals, while some crystals may be very hard compared to others which are very brittle. These difference in properties decide on how these crystals will be used in certain situations. There are also two main types of crystals that exist. There are single crystals, which are comprised of just one large crystal. These crystals are oftentimes used in simpler applications compared to polycrystals. Polycrystals are crystals that are comprised of many small crystals, also known as grains. These polycrystals can be used in many different types of scenarios due to their wide range of properties. When comparing single and polycrystals, there's more to look at than just the fact that single crystals are just one singular crystal, while polycrystals are made up of much smaller crystals. A big difference between them is the fact that properties of single crystals can vary with direction. This is known as anisotropic, while the properties of polycrystals may or may not vary with direction depending on the orientation of the grains. If the grains are randomly orientated in the polycrystals, it is isotropic. Well, if the grains in the crystals are textured, then that means that it is anisotropic, just like single crystals. Like I mentioned before, some crystals will have different properties when compared to other crystals. This difference in properties can come from how the crystal is formed and what material is used to form the crystals. There are certain qualities of crystals that are more important than others. These important qualities include the hardness of the crystal, the optical properties of it, the heat conductivity, and the electrical conductivity. These properties will determine where crystals can be properly utilized. Now I want to go over some of the uses for the different types of crystals. To start off, I'll look at the uses for single crystals. Single crystals can be used to make turbine blades for some jet engines. They can also be used in certain semiconductors and detectors such as infrared and radiation sensors. Now here are some uses for polycrystals. The uses for polycrystals are pretty different compared to the uses of single crystals. Polycrystals can be used to create transistors for certain circuits. There's also the fact that polycrystals can be used to create conventional solar cells that are needed to create solar panels. Now I want to talk about the two crystals that I made myself. I created two crystals at home using two different starting materials. I used these two different starting materials to show how the starting material can change the formation of the crystal. I first want to talk about the process I went through to make these two types of crystals before I show you the final product that came out of the experiment. First, I started with bismuth crystals. I took the solid chunk of bismuth, put it in a pan, and then heated it to 450 degrees Fahrenheit. After it finished melting it, I took it off the fire and then let it cool off for a bit and then recovered whatever bismuth crystals were left at the bottom of the pan. After creating the bismuth crystals, I then went on to create borax crystals. Borax crystals was much simpler to create than the bismuth crystals. All I had to do was heat up water to about 90 degrees Fahrenheit and then pour in a certain amount of borax into that water. After pouring in the borax, I would then stir it around until the borax was completely dissolved in water. And once it was dissolved in water, I took the borax solution off of the heat and let it cool down for a couple hours. After letting it cool down for hours, I noticed borax crystals start to form. I left it for more hours, and when I came back the next day, I had a fully formed borax crystal. Now I'll show you what the two crystals ended up looking like after both experiments were completed. These are the two crystals that I ended up making myself. This one on the right is the borax crystal. As you can see, it has many rectangular shaped crystals that are very large on this one. And the one on the left here is the bismuth crystals, which has a much more unique shape to it compared to the borax one, but I could only get much smaller crystals from it.